Okay, so we are done with geometry. We're going to talk a little bit about probability. So today we're going to talk about the fundamental counting principle. Um, this is actually pretty easy. So it says a person's odds of winning the Powerball jackpot are about 1 in 292.2 million. The jackpot sequence is selected from 5 white balls pulled out of the drum of 69 balls. Then a red ball is picked from the drum of 26 red balls. You have to pick both to win the jackpot. So you need to have all 5 white and the one that's red. So that was the Powerball. So the estimated jackpot on January 13th, 2016 was 1.5 billion. So this is your odds right here of winning that jackpot. Let's see how these compare to other things. So you have a 1 in 292.2 million chance. So your odds of being a victim of a serious crime, murder, assault, robbery, or rape is 1 in 20. Your odds of being born with 11 fingers or toes, 1 in 500. Odds of becoming a professional athlete, 1 in 22,000. Odds of dating a supermodel, 1 in 88,000. Odds of being struck by lightning, 1 in 700,000. Odds of becoming president of the United States, 1 in 10 million. Odds of getting attacked by a shark, that's 1 in 11.5 million. So that averages out to 5 a year. All of those you have a better chance of doing than winning that jackpot. What are your odds of being attacked by other animals? So it says not even close to the animal that kills most people per year. So cows kill 22 people, ants kill 30, jellyfish kill 40, deer kill 130, hippos kill 2,900, and humans themselves kill 16,260. Your odds of winning $1,000 in the McDonald's Monopoly game is 1 in 36,950,005. So you have a better chance of winning the Monopoly game at McDonald's than winning the Powerball. So it says in this section we will begin by preparing for the surprising world of probability by looking at methods for counting possible outcomes. So we have a tree diagram here. So it says, let's say you're getting dressed to come to school. You have to choose from, so you have 2 pairs of pants, black or blue, 3 shirts, so you have blue pants, black pants. You have 3 shirts. You have white, yellow, and blue, white, yellow, and blue. So if you wear the blue pants, you can wear the white shirt, the yellow shirt, or the blue shirt. If you wear the black pants, you can wear, again, the white shirt, the yellow shirt, or the blue shirt. So this would give you 6 total options. It says we can use a tree diagram in order to demonstrate our potential choices. We can generalize this idea to any 2 groups with the fundamental counting principle. So what the fundamental counting principle says is if you can choose one item from a group of m items and a second item from a group of n items, then the total number of the 2 item choices is going to be the product of m and n. So you're going to multiply. So in this case up here, I know I have 2 pants and I have 3 shirts. 2 times 3 would be 6 different options. So let's try that out. So Five Guys Burger and Fries franchise offers 7 side slash extras and 14 main meal choices. How many ways can a person order a 2-course meal? So you're going to have 7 sides times the 14 main courses. And you're just going to type that in your calculator. So 7 times 14, 98 ways. So using the fundamental counting principle, there's 98 ways. You could do a tree diagram for that, but that would not be fun. Another restaurant offers 10 sides and 15 main courses. How many ways can we order a 2-course meal? So you have 10 sides times the 15 main courses. This is going to be 150 ways. So just multiply them and you'll get how many different combinations you can have. So let's apply the fundamental counting principle. It says, for next year's schedule, you must take a math class and a science class. If you have the following to choose from, 4 math, 5 science, how many different 2-course schedules are possible? So if I need to have math and science, you're going to multiply the math and the science, and you're going to get 20 schedules. So there will be 20 different schedules that you could have if you had 4 options for math and 5 options for science. Let's say that we received a new pair of shoes for our birthday. Now we have another choice in our morning wardrobe. Now we have the choice of red or black shoes. We can expand our tree diagram for those choices. So now you see with every shirt comes 2 pairs of shoes. So you have 2 choices. You have 1, 2, 3, 4, 5, 6. This will give you 12 choices. So the fundamental counting principle says the number of ways in which a series of successive things can occur is found by multiplying the number of ways in each thing that occurs. So here you have 2 pants, 3 shirts, and 2 shoes. 2 shoes. So if I take the pants times the shirts times the shoes, you're going to get 6 times 2, which is 12. So all this is showing you is you can add however many different types of items you have. You can multiply all the numbers that go with those different items. So as a requirement to graduate, you must take a math class, a science class, and an English class, and a social studies class your senior year. You have the following to choose from. You have 4 math, 5 science, 2 English, and 3 social studies. You need all 4, so you're making a 4-course schedule. So you're going to have 20 times 2 times 3. This is going to be 40 times 3, which is going to be 120 schedules. So there would be 120 different ways that you could take these classes. Do the same thing with this one. Let's say you're feeling lucky and you want to just guess the answers for your next exam. If the exam has 10 questions with 4 multiple choice answers, how many ways can you answer the question? So you have 10 questions and there's 4 answers per question. So that'll give you 40 ways to answer the questions on these tests. Okay, cell phone numbers and telephone numbers in the United States begin with a 3-digit area code followed by a 7-digit local telephone number. Area codes and local phone numbers cannot begin with a 0 or a 1. How many different telephone/cell phone numbers are possible? So the first thing that this is showing us is that these can't begin with 0 or 1. So a lot of people mess this up. You can have the numbers 0 to 9. A lot of people want to say there's 9 numbers there. But if you count them, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So there's 10 choices for anyone that can be 0 to 9. However, the first one of the area code and the local number cannot be a 0 or a 1. So you're taking 2 out of there. So there's 8 numbers that can go here. There's 10 numbers that can go here, and 10 numbers that can go here. Same thing. This red square, there's only 8 numbers that can go there, but there's 10 numbers that can go in every other spot. It doesn't say that nothing can repeat or anything like that. The only stipulation we have is 0 and 1 cannot be used for those first two. So you're literally going to multiply all of these. There's going to be a ton of different ways. So 8 times 10 times 10. This is going to be 800. And then we're going to multiply these in the end. And then you have 800 again. And then you're going to have 10,000. So 10,000 times 800 times 800. There's going to be so this would be hundreds, thousands, millions, trillions. So you're going to have 6.4 trillion, or billion, sorry. I messed up there. It's going to be hundreds, tens, hundreds, thousands, millions, billions. So this is going to be billion ways that you could do this. That is a lot of different phone numbers. So you're just going to take everything and multiply it together. That's how that one works. You may have ones like this on your homework. Okay, so this is very similar. An electronic gate can be opened by entering 4 digits on a keypad containing the digits 0 to 9. So again, you have digits 0 to 9. That's 10 numbers. That's important. How many different keypad sequences is possible if the digit 0 cannot be used for the first digit? So you have four numbers here. 0 cannot be used for the first one. So that would be 9 options, then 10 options, then 10 options, then 10 options. This is just going to be a 9 with 3 zeros. There's going to be 9,000 ways for this one. So the only thing tricky about this is knowing when you're going to take a number off, like we did here with that one. So we're going to work on the homework tomorrow. Hopefully you have a good day. And I will talk to you again on, I think, Thursday. If not Thursday, it'll be next week. So I hope you guys have a great day.